Hello, hello. This is Postgres FM, podcast about Postgres, as you can guess. My name is Nikolai from Postgres AI, and as usual, my co-host, not guest, co-host is Michael from PG Mustard. Hi, Michael.
Hello, Nikolai.
So you chose the topic, and it is
Slow counts, or like why is count slow and what can we do about it?
how to make count slow. You just count. Yeah. So yeah, let's discuss. I don't know. For me, it's super old topic, and I'm not sure I will use some fresh knowledge here. I have a lot of fresh knowledge about Postgres, and I share constantly. But this is something which is super old. There are improvements we can discuss, and like index only scan, we talked about them recently a lot. But I guess my role will be to use my knowledge from, like 15 years ago, mostly. And just before we started this recording, I shared with you how I a little bit helped Postgres to get rid of count, right? Because sometimes you don't need it. So I'm going to stay in that area 10 years ago. And if we have something new, I will be just putting more to-do items to my to-do list, right, to explore, and that's it. Maybe you know some things better than me. Let's see.
Yeah, well, the Postgres link is great because the resource I still like to point people to on this topic, the best thing I've ever found on it is a blog post by the Postgres author, Joe Nelson, on the Citus blog. So I'll link that up for people that I think explains it in a lot of depth, but in 2016. So quite a long time ago, in 8 years at the point of recording. And I was kind of surprised how many things had changed, but also how little has changed in a way. Like there are optimizations, a lot of things that were kind of little gotchas back then aren't true anymore. There are a bunch of ways that it's faster now by default, but the essence of it is still true. Like because of the way Postgres does MVCC, when we do
because
an
it's row
aggregation, because it's row store, yeah. Basically, because all the things that make it great as like a transactional database count against it, and a pun not intended, when it comes to aggregating across a lot of data. And count is, I think, at least in my experience, that's the most common aggregation people want to do in like typical use cases.
Yeah, that's a good point. Since Postgres row store, it's better. Like imagine you have a table users, for example, as many SaaS systems or e-commerce systems do, like customers, users. Since Postgres is mostly like OLTP, row store, OLTP focused database system, it stores a tuple, a row. If it's not too wide, it stores it in one place, in one page, basically, right? As we discussed many times, a page is 8 kilobytes by default in most cases, and very roughly, if a row doesn't exceed 2 kilobytes, it will be in the same page, and that's it. It was not the mechanism called toast won't be involved. If it exceeds it, it will be shrinked to pieces and stored in additional table called toast table. So imagine we have a users table, and then users can log in. So we need to retrieve information about this user. And it's good because all information about a single user stored in the same page, right? If it's narrow, right? As I said, it means that it's quick to retrieve. It's just one buffer hit or read.
Yes, extremely efficient for like if we wanted to show the profile of that user, if we wanted their name, their age,
email.
Loads of information about them, a single page read to return that. Incredible. Or maybe like a couple once you look them up in the index, then
right.
So the heap page.
So it's very IO optimized, basically.
Efficient?
Right? Efficient, yeah. Exactly. But if it comes to counting or calculating some like sum or average, minimum, maximum, everything like aggregates, it's not good, because usually aggregates we deal with only a single column or a few columns, and we don't need all the other columns this table has. If we have a row store, as Postgres is, in this case, it means that we need to do much more I/O many more buffer operations, hits and reads, to get information for like to calculate aggregates for a single column. For example, count them, right? And it means if we want, for example, very, very, very common ask in startups, in social media, in SaaS, in e-commerce, let's just show how many new users we have every day. We need to count daily, right? And this means, like, imagine if we have only few records in 8 kilobyte page, few users records, right? Few users tuples, because we have many columns, right? It means one buffer operation will give us, will allow us to count only like 4 users, 6 users, and that's it. Compared to column store, where each column is stored in separate files, and if this file is about ID, it's only ID, right? If it's about creation time, it's only creation time, date time, right? In this case, counting is much more efficient because one page can bring us many more users and we can count them much better, right? This is quite straightforward and very simple, trivial comparison of column store and row store, and why in column store aggregates and counts specifically are much faster than in row store, just because of I/O, right?
Yes, and that before you start to think, like, I think because column stores are used for these aggregation and analytics use cases so much, I think they tend to have more optimizations around these aggregations as well than at least at least like the old school transactional processing databases have. I think lines started getting blurred a little bit with some of the extensions, like some of the newer extensions in the Postgres world that also have some of these optimizations. But yeah, I think that's a great starting point as some of Postgres' strengths working against it. I think another one that is not just row store versus column store is because of how Postgres does visibility. I think if you look at some other transactional process databases, because they don't do like the same marking pages as not because they do undo logs basically.
Right.
They can also cheat a little bit for certain counts. Like if you want to count all of the users, which if you have like some specific use cases, like let's count all of the records in this table, they can keep they cheat and do some of the like solutions that we're going to discuss.
Well, they're not cheat. They put new row version in the same place as old row version. It means that compactness, if we have already compactness of storage, it's not lost. Compared to Postgres, where new version comes to new place, maybe different page. In many cases, it's a different page. Maybe it's a place which were taken by another tuple which became dead and then vacuumed, deleted by a vacuum, right, or auto vacuum. It means that we might end up having very scattered storage for our tuples, especially if we need to count only specific tuples. So we have the where clause in our select count. It means that we need to, or we might have index scan for this, but it's kind of random access, right? We need to count many tuples which are stored in random places, and we don't use partitioning. Our table is 1 terabyte in size. It's super bad case. In HUpdate randomizes with storage, right? New version is stored in random locations, and it becomes worse and worse and worse. It's very scattered, and we lose compactness. This is how MVCC in Postgres works, unfortunately. We oftentimes say it's more like rollback focused than commit focused, because in case of rollback, new version becomes basically dead eventually, right, and cleaned up, and old version remains in the same place, and we don't lose compactness. If we have commit, we move rows all the time. We move tuples, physical versions of rows all the time, and we lose compactness eventually, right? And this is bad. This is bad for count, bad for other aggregates as well.
Yeah. So I think that's like a good overall summary of why count is slow, like, or at least why it scales
bad, right?
with. Yeah. Or what I think while it's It's not bad on tiny data sets. It's fine, right? It's you probably won't notice it too much. But as data scales, even in the blog post I was reading, they only did a data set of 1 million rows, and already even like the fastest optimizations at the time could only get an accurate count in about 100, 200 milliseconds, something like that. So we're already talking about like 10x what you would consider a fast query. So even at 1 million records, which is not many in many use cases, we're talking about potentially a meaningful length of time. So yeah, I think, should we move on to what we can do about it?
Let me share the history of this blog post. I might somehow provoke that blog post John Nelson wrote a little bit, and I'm not taking full responsibility for that blog post, definitely. But I remember he published it in 2016, right? And I started using it all the time. Like I shared, like if you want to understand count, just read that blog post. Of course, right now I would say it's missing buffers in the explain plans for sure, because as we just discussed, IO is reason number one of why things are slow, right? We should not talk about timing only. We should talk about buffers as well all the time. But back 1 year earlier in 2015, I started looking at Postgres, which right now is one of the main building blocks Supabase has. And I was impressed, like, great, we can ditch Django and Rails applications completely in simple, at least in simple cases, and do everything on server side and front end. This is actually at the same time React became popular. I think it started in 2013, 14, and so on. So it skyrocketed at the time in 2015. And a lot of business logic went to front end, of course, also React Native. Great. So we need to get rid of middleware, keep data-oriented business logic in database, keep UI-oriented business logic on client side. And this is great. So I found Postgres, and I quickly realized I came from already quite heavily loaded systems. I remember, for example, first time I saw integer 4 primary key exhausted, it was in my own project in 2008. So I already realized some data volumes and how they work in Postgres. And I quickly found that in Postgres, they had already some pagination, very good. But on each GET request, you say, I want only 25 items on my page, but they also show you how many overall items you have for this request with all your filters and so on. And I thought, well, that's not good. I know Postgres has slow count, right? If every time they count it, so it's written in Haskell. So I started digging inside source code, and I found indeed it runs count all the time. So I helped them to get rid of it by default. So I remember I created issue. Let's get rid of count by default, and they quickly agreed and removed it. So I'm happy I helped a little bit to realize that count should not be used by default. And also at the same time, John Nelson, the original creator of Postgres, started to dig into this topic and found several alternative ways how to make count fast, including approximate method. Right? I like this method. It doesn't work all the time. It works very well if you have AutoVacuum well tuned, so it runs auto-analyze frequently, right? Because you need fresh statistics. And it also works if you don't play too much with filtering. So for example, if you have users table and you know to display overall count of rows in this table, you can use just approximate approach, which, like, in few words, you just run explain without analyze. You just run explain, select star from users, right? And the planner will tell you how many rows it expects. And this is already approximate number you can use. Right? This is all trick I first learned maybe in 2004 or 5 when I started with Postgres. We used it.
I think this trick comes into its own for things that are harder to find out from the statistics or from other methods. I think, like, for example, if you have dynamic filters that users can set, or if you need to be able to set arbitrary where clauses, or you want to be able to join relations and get estimates, then this is an extremely powerful estimation tool, because you're basically using Postgres's planner to do it.
But you need to make
for all the
sure
reasons
it's up to date most of the time.
Well, it's not even that's not even enough though, because we've had plenty of episodes where we've talked about times where the planner's estimations can be way off. So
yeah, just have two columns and two filters, and don't have multi-column statistics. That's it. It's
exactly.
super easy way.
Yeah, or in two different tables, like where you can't even. So we've talked about the limitations of that before, but in the real world, I've seen very few. I mean, it's probably a limitation of my experience rather than because I've seen how popular these estimation tools are. I've seen very few cases where people would rather have an estimated count than no count at all. In lots of user-facing applications, I've seen people want an exact count or they don't want to show it. And that there seems to be this...
I cannot agree. For example,
where do you see it used?
Well, for example, I had this. We have a social network, for example, and we just want to display the total number of registered users and the total number of, I don't know, like groups created or anything created, posts, comments on the front page. And it's just overall number. Definitely this approach will work there very well. And we rounded it. We don't show, well, next idea, let's round it, but also show some, if we know current number and 1 week ago number, so we can understand the velocity, the speed of growth, and we can also pretend it's growing right now. It's like fake, but this is what social media do all the time, right?
But this is kind of my point, that you wouldn't use the actual... So the number, when it's an estimate, could go down. Like even if it's like a number of you, like in that case, you wouldn't want to show a number this week that was lower than the number last week.
Right. You're right.
So you still wouldn't use the exact, so to be more specific, there's some really cool algorithms. There's a really popular extension called Postgres Hyperloglog. Yeah. And
count distinct.
So it's for estimating count distinct. You're right. So more specific than just count, but it's available on pretty much every cloud provider, which makes me think it must be pretty popular. Like it must have been requested on a bunch of these.
Not necessarily. Things work in life differently. It might be just, we don't know how popular it is overall. It might be just cool to have it at some point. Sometimes people have high expectations, and also in case of managed Postgres services, is in any areas of business, any segments of market, if some big player added it, others also add it. This is what happens.
Even if, let's say only one big customer needs it or wants it, if they're big enough, maybe you add it.
Yeah,
just to
also might
them.
happen, yeah.
So good point. But I do think this whole category of estimated counts is super interesting, and that feels like one big solution that you can say, look, your count is slow. One option is estimating. And I think it's really interesting intellectually, and I'd love to hear from people that do use it in production for real things. But it very often I see people say, okay, that's cool, but what are the other options? Like what else can I do?
Let's finish with when to apply this proximate approach. I think it's, if you need count of rows in one table, it's easy, like no filtering, it's definitely an option. But you need to make sure AutoVacuum is configured to trigger, like AutoVacuum analyze scale factor is configured properly, so statistics is up to date most of the time, I would say. But also, if you have filters, these filters should be like single column, no joins. In this case, is good, right? In some cases, it can be not good as well. For example, if you need daily, it might be current day might be off completely, or if you have many, like if your project already is old, you have many years of data, daily might be also challenging, because we know by default Postgres keeps only statistics for 100 buckets.
Oh, interesting.
Statistics
target. I see where you're coming from.
But we can raise it. We can raise it for specific tables, even specific column. And this can help as well in this case. If we know we do like daily or like monthly counts, we can change this setting and have more precise statistics, right? And still use a approximate approach. Make sense?
Yeah, I think it might even be simpler. Like it might be that most people don't end up going this route because they actually find they can live with the trade-offs of the other approaches. Like it feels like a last resort estimation. If you've got a slow count, maybe you're thinking, well, can we make it like there are ways of making it faster, but they come with certain trade-offs. So maybe we should discuss those first and then come
Let's
back
do
at the
it.
end to say if you can't live with those trade-offs,
Yeah.
then you have to and you still want to display something or show something.
For me,
then
it's
you have
vice
to resort
versa,
to
actually.
estimation.
Count is approximate count is super easy to implement. I would consider it first. Would it work well enough in our case, or we exclude it completely? That's it. Because it's super easy to implement. But let's move on. You already started talking about hyperlog log, right? This is for distinct count, and this extension is indeed available almost everywhere. So if you have count distinct, why not consider it, right? Because it might be very good, fast, and so on. And Joe Nelson in this old article explains it, right? So what I would do, I would consider it in this case. I would do some benchmarks with current data volumes, but also 10x, for example, predicting for future growth with focus on IO. I definitely would look at buffers numbers in the plans and understand how, like, what about scalability here? If we scale 2x, 5x, 10x, will still IO numbers be fine and leading to acceptable latencies or no? This is the question, right?
But we're still in estimation, right?
Yeah, but it's more like it's smarter already, right?
Yeah, true. Smarter than just relying on Postgres statistics stuff. Yeah, true.
And next, like I know the article also just like it's interesting that we discuss the article which is 9 years old or how many 9, right?
Well, I did as part of my prep for this. I did run. They conveniently they provided like code snippets for each step, and I didn't. I did a few changes, but it was very, very easy for me to run this on Postgres 17 actually, just because I was doing some testing.
What changed?
Well, so the first thing I noticed was his plans didn't even have parallel. Like, bear in mind, if we're talking about doing a count over 1 million rows, these days you just expect to see the first query plan have a gather and
3 workers by default, basically. Main
yeah,
one.
or yeah, exactly. Exactly. And I didn't, and I was like, wait, so his blog post was pre Postgres having parallel workers. So that was the first
it means
thing.
roughly it should be by default 3 times faster because aggregation, like append, how it's called, it's easy in this case. It's just sum of numbers. That's it, right?
Yeah, count should parallelize really well.
Yeah.
Because I don't know his hardware, I could and I didn't go back and like try and get a really old version of Postgres. I didn't actually. I probably could have just tested by turning off parallelization. But yeah, probably about 3 times faster.
Mm-hmm. Good. This is a good point. Yeah.
Yeah, that was the first thing I noticed, and then there were a couple of other differences in the nitty gritty, but nothing like fundamental, nothing like too big. So most of the points still stood really well, even though, as I said, it was like a lot's changed, but also not that much has changed. So yeah, another one was in the past you had to do a workaround for. You needed to use a subquery trick for like count distinct to get an index only scan. So instead of being able to do count distinct on column and get an index only scan, you had to do like a select within that. So you had to do select distinct to get the index only scan. Don't need to anymore. That was quite cool to see.
Yeah, that's a good point as well.
But yeah, like a bunch of so actually index only scans, we should probably talk about that while we're
we just had the episode about it a month ago, so it's very related to the ideal case for Postgres in its row store situation. It's index only scan with low heap fetches, ideally 0, right? Which means again that leads to the need to configure to vacuum to make it work more frequently and move on faster. Right. In this case, if it's on the index only scan, this is the best we can do with Postgres. Parallel index only scan, maybe, as you said. And this is good. I mean, this is the best thing you can see in plans index only scan with low heap fetches. The only better situation would mean you need to start denormalization, caching, and so on. And it's like I would consider it as heavy solution to the problem, right? Because
yes,
this would give you a few buffer operations to retrieve your count. If you have fully denormalized, maybe, for example, materialized view, I would not recommend using materialized view in complex projects at all. Default materialized view. But consider we have it already and we have proper index on it. Finding proper count would be just finding like maybe one row, that's it, one value. It's like primary key lookup, right? Or maybe just index lookup to find one record. That's it. It's super easy. But to achieve that, first of all, it requires effort. You need probably triggers or asynchronous triggers somehow. And second of all, if it's not materialized view, you need to have something probably with desire to support partial refresh, because default materialized view supports only full refresh, which is not efficient in most cases and can lead to bloat itself, bloat inside materialized view.
So I've seen people implement versions of this and use off-the-shelf things that are kind of in Postgres extensions for this as well. So this is actually that's the approach I've seen most commonly used for this, because it doesn't scale with volume. I think this is really attractive because even an index-only scan, if you double the data size, you're going to roughly double the time it takes to do the count. So you're going to keep bumping into this problem down the line. Whereas,
well, yeah, you're right. If you double, even with the index-only scan, we still need to. For example, if we forget about structure completely, talk about only about leaf nodes. If we have 2 times more values to store, we need 2 times more pages, right? Two times more leaf nodes, and it translates to 2 times more IO operations. And of course,
and even if it's not 2 times, it's still like it still degrades over time, and
not better than
these counter caches.
Not better than 2 times. It can be even worse, but not better, because if you need to keep references to 2 times more tuples, you do need more space in leaf nodes, right? 2 times more leaf nodes, at least, maybe more actually, if we have like balancing situation and again, not compact storage of tuples and so on.
Yeah. So on the index-only scan, actually, I think it's worth, before we move on from that, worth thinking about because I think that goes back to the beginning of the conversation. You talked about row store versus column store. If we have an index-only scan on only a single, relatively small, like let's say a primary key, for example, that we can then use to count, it's ordered as well, so it can help us with count and count distinct. It's almost column store like in a way, because if we only have to search the index, we're searching like a single column effectively. So we're almost getting that column store benefit without some of the aggregation tricks that some of these column
leaf nodes are double linked in both directions, so we avoid traversing of whole tree. We just like at the beginning of the first value, and then we just go scan leaves only, and that's great. I mean, you're right. If it's index only scan, we don't care about other columns. But interesting point that we need to make sure we select count, like select count star, we'll probably choose some index, most likely primary key, right? But if you count some column which allows nulls, like we had very long ago, we had episode about dangers of nulls, and this is one of dangers because count, if it's null, it doesn't count. Count doesn't count nulls, right? This thing might be surprising in some cases, even for experienced folks. I surprise myself with this once per couple of years at least.
I see this so often in kind of philosophical, like people talking from a computer science perspective, people asking like, what's faster, count star or count one or count ID or thing. But I've never in practice seen any use for anything other than count star. Have you?
Well, in some cases, I specifically count not null values in some column. So I put the column there and that's it. In many cases, I count with additional filtering. You know this, it's already not new. It's like 20 years old, but filter extension of
Yeah.
like you say count star, this is our overall count, and then instead of doing these very heavy structures in SQL like case when blah blah, case when else, I don't like them. So instead of that, you just say count star or column filter and then in parentheses where, and this gives you opportunity to count many things in one go, right? You just have
One scan.
yeah. So it's filtering on
It's
the
really
fly.
cool.
If it suits your filter conditions, then it will increment your additional counter. So you have multiple results in one select, multiple numbers returned, right? And that's great thing. And in there, sometimes I use colon, understanding that nulls won't be counted. In this approach,
Makes
right?
sense.
For example, I want to understand how many people fill this value, again, users table. And we have, for example, Facebook ID. It's null if Facebook was not connected. In this case, you say count star means overall number users registered daily, for example. And then you say count Facebook ID, counting only those people who connected their Facebook accounts. Makes sense, right?
Yeah.
In this case, you don't need filter. So it's kind of just maybe syntax sugar, right?
Yeah, I have seen an argument that star is misleading because it doesn't mean what it means in other contexts, and maybe we'd have been better off if it was like count and then parentheses, but nothing in the parentheses would have been.
I actually agree with this, because if we propagate this logic about nulls, star should mean none of columns are null. And this is always so.
All of the columns are not null. Yeah.
So let's talk about this generalized approach. I think this is most powerful, but requires effort. And
well, it depends.
Mm-hmm.
I think there's like some really simple approaches that have some big trade-offs, and then there's some more complicated approaches that have like fewer performance trade-offs, but they were more complex to set up. Like, for example, I think adding a trigger that, like, let's say you know what you want to count, and you're able to, maybe you're doing a bunch of reads but not many writes to this table, and it's already quite big. So you're okay to pay a little bit of overhead on each write in order to maintain just literally a counter.
Did it many times. But you know what will happen, right? Under load.
Okay. Yeah.
Especially if you have foreign key, as I remember, there are issues because multi-exact ID and contention. And imagine you have count, like, this popular anti-pattern many people do in the beginning of their career when they try to develop some accounting part of their systems.
Like debit and credit.
Yeah. And they have like common account or something, like counting all the money flow. And this requires updates to single row in some table. Any transaction, financial transaction, triggers this update synchronously, and this becomes quickly a hotspot, obviously, because if you have two SQL transactions, doing some financial transactions, that by trigger they try to update this single row, they compete. This one will be blocked until another finishes with commit or rollback, right? And this it doesn't scale at all.
Well, but I've seen solutions to that. Like, I've seen somebody, I think it might have even been Tobias Petri. It might have been one of his Twitter tips. All you do is you add more. Like, if you split
append only table, right?
No. So you have, let's say, 10 to keep it small counts, and each write triggers updates one of those, but you don't know which one. It random. It updates one of them, and then if you want to count everything, you have to count all 10 values.
Batches, basically,
and then,
right?
So it removes it spreads the heat.
Yeah, this is one approach. Second approach, if you, for example, have some, it's not easy, I would say. And batching is already a good thing, but it's also like, okay, you basically reduce contention, but you don't eliminate it. Full elimination would require a synchronous trigger.
All I meant is it's quite simple at low scale. Like, it only gets complex at higher scales.
Yeah. I also did it. Like, let's increment by 10 all the time or by 100 in jumps, but it becomes already not real time. It's okay. But ideally, in heavily loaded systems, it should be asynchronous. So normal writes don't trigger immediately. They don't lead to increments at all, and they just register event, something happened, right? Or they just are there, and we will retrieve them by selects, and that's it. Yeah, synchronously we do processing with batches as well.
Do you know the favorite thing I've seen for this is, well, other than maybe some proprietary solutions, is simple roll-up tables. So maintaining a count of like older stuff in bigger batches. So like you might do yearly count and then a monthly count, then a daily count, and then anything since that day, you go through all of the data. But it means that over time, you can roll things up into like bigger aggregates. And I think that to me scales really well.
Yes, but the main approach, naive, simple approach, let's do synchronous updates and we will immediately have hotspot. It's bad. Then, okay, asynchronous approach. There are two like sub approaches. One is pull, like every minute we pull, look, oh, do we have some new data? If we have it in one batch, we issue update every minute. It's okay approach actually, and reduction of it's actually a regular materialized view, and you just refresh it fully from time to time. It's super simple relatively, and it lacks partial updates. This is probably very annoying. So materialized view is very rough approach, regular materialized view. If it's PG IVM or how it's called, it should be better. I haven't tested myself, and I needed to confess. I had big plans to test Hydra, right? This new thing with DuckDB, right? PG DuckDB or something.
Yeah.
This PG IVM, I have so many things on my plate to test for maybe already not months, but years. But unfortunately, I must confess, customers with managed Postgres with their own needs occupy our time lately most of the time, because we try to do things which don't require extensions, RDS, Cloud SQL, and others don't have. I wanted to mention PGQ. PGQ is present in Cloud SQL, right? It's interesting. So Cloud SQL users can use it and benefit from it because it's very old and very well battle-tested solution from Skype. So imagine, imagine if we have some things we can register in PGQ, it will take care of scalability because it has partitioning inside and so on. And then we just, it's like push events, and then consumers of those events, they increment count, but also maybe in batches and so on. So so issue just one update to increment by some number, right? And this improves things a lot and makes system more resilient because legs will be lower. It can be not PGQ, but something like Kafka or I don't know, like a Sidekick or what you have, like Celery, if you Python guy, right? But with this asynchronous nature is really good, and nobody likes actually delays like 1 hour, because you start with 1 minute, you say, okay, it's acceptable, but system grows. And then you say, okay, we need to reduce frequency to like once per 5 minutes now. But it then grows again, once per 10 minutes now. But if you have asynchronous push through asynchronous message queues or something like event processing system, in this case, you can build good asynchronous kind of trigger, right? I wish Postgres had something internally and every managed service provider supports it, so all our customers already had something. But right now, unfortunately, it requires effort and you need to build with things you use, sometimes outside Postgres like Sidekick or Kafka or something.
Yeah, I think we've mentioned pretty much everything from like vanilla Postgres without extensions at the moment. Yeah. But there are a bunch of other interesting projects. I agree. I think the DuckDB stuff, especially that cross-company initiative, seems super interesting. But there's at least a couple of projects at the moment pushing some of these analytical queries to a column oriented.
But we
file.
need to keep in mind that this also brings additional challenge. Again, this means you need denormalization because you have original table as source of truth and you need to bring data to extra table or something and maintain this relationship all the time. So it's consistent and not lagging too much, right?
Yeah, but I think the optimizations they add might then be worth it in a lot of cases, like like the column store and then the vectorization. Like there's so many benefits once you pay that. Like if you're willing to pay that upfront cost,
you can also you can also do more like I would say it's already traditional architecture when you have analytical system in addition to Postgres. It can be I don't know, like it can be even ClickHouse. It can be Vertica if it's old, or these days Snowflake. And we know PeerDB was recently acquired by by ClickHouse, right?
ClickHouse.
And it means, imagine we have like our OLTP storage with users table, and then through logical replication, it goes to ClickHouse, for example. And there you can do any counts with good speed, right? Any analytical, you can move analytical workloads, which are maybe even user facing to there, right? It's also worth considering, but it moves us outside of Postgres, and I don't like it personally.
To stay kind of within Postgres, I think the work the Citus team did was super interesting because I think they were largely used for these large analytical workloads where they used the fact they had sharded to multiple nodes to let you parallelize some of these queries. So it gained from some of that extra parallelization. And then the other company doing some interesting stuff in this space, I think, is Timescale, who've added some optimizations, added some functions for. But I think
continuous aggregates is a great thing. Yeah.
Yes, and continuous aggregates means that they've done a lot of that heavy lifting. If you have access to Timescale, if you're self-hosted or on their cloud, then you don't have to do all the complicated stuff.
And if you have not only access to Timescale, but to proper Timescale, because when some company says we support Timescale, but it's only, how is it called, like Community Edition?
Apache. Yeah. I get confused. I think they actually, Community Edition is the one that you can't use. It's the Apache 2 one that you can use on other clouds.
Yeah, some clouds support Timescale, but only this reduced option.
Yeah.
But full-fledged Timescale is a great thing to have. Definitely compression plus continuous aggregates. We have it in a couple of places. It's so great. And this is it. Like, it's flavor of Postgres, which I do like, but it's not available if you're already deep inside RDS or so. You need to consider migration and so on. Yeah, Timescale Cloud or self-hosted.
Exactly. So yeah, and then the last thing to bring us back to a topic we talked about last week is they have an implementation of loose index scan for count distinct. You can use your own implementation of loose index scan,
like in Wiki, right?
Yeah, exactly.
With the Cursive.
Yeah. So that's pretty much everything I had.
Yeah. So I think we covered basics. If you want to deal with billions of rows with hundreds of thousands of transactions per second, it's not an easy topic, actually.
Thanks so much, Nikolai. Catch you next week.
Yeah, bye. Thank you.